Namaskaram. The process of finding absolute extrema for a multivariable function depends nature of the domain. There are four types of domains: closed and bounded, closed and unbounded, open and bounded, open and unbounded. In this course, we will discuss only absolute extrema on a closed and bounded set. Okay, let's start. The solution of last homework. Okay, so we consider a closed and bounded set R, and then we have an algorithm for finding the absolute extrema. Absolute extrema means either absolute maxima or absolute minima. Okay, so the step one is find the critical points of fxy that lies in the interior of R. Okay, so we have to find the critical points that lies interior to R. That's our step one. Okay, step two. Find all the boundary points at which the absolute extrema can occur. That means uh, since since absolute extrema may occur on the boundary points. For this example, at B it has a relative maximum, but on this domain here the domain is nothing 0 1 cross 0 1, right? A square like this. On this example, its absolute maximum occur on the boundary point. Okay, so this may happen. So that's why our step 2. I will explain the step 2, that is how to find such extreme points on the boundary using next example. Now we have finite number of points, that is some points from the interior, they are critical points, and some points from the boundary from our step 2. Then step 3, just evaluate fxy at the points obtained in the preceding steps. That means you just evaluate f of x, f of xy on these points. Okay, in critical points and boundary points from the step 2. The largest of these values is the absolute maximum and the smallest is the absolute minimum. This is the procedure of finding absolute extrema on a closed and bounded set. That is very important. Okay, consider a problem. Find the absolute maximum and minimum values of this function fxy is equal to 3xy minus 6x minus 3y plus 7 on the closed triangular region R with the vertices 0, 0, 3, 0 and 0, 5. Okay. Okay, this is our triangular region R bounded by triangle with these three vertices. Okay, so it is clear that this region is bounded and closed. It includes the boundary. Okay. So step 1, what is our step 1? Step 1 is we have to find all the critical points of this function lies interior to this region R. Okay, so we have to find all the critical points inside the triangle. Then how to find the critical points? Yes, to find the critical points, you have to find fx and fy, then equating to 0. Okay, fx equal to 0 and fy equal to 0. So what is fx and fy and what are the critical points? Yes, fx is 3y minus 6 and fy is 3x minus 3, and we have to solve these two equations. So this implies you can take 3 outside and cancel. So this becomes y minus 2 equal to 0. This implies y equal to, and similarly here 3 is common, you can take outside, cancel, and this implies x minus 1 equal to 0. That implies x equal to 1. So this function has only one critical point. Whatever be the points, whatever be the domain, this function has only one critical point, that is 1, 2. Okay, so 1, 2 is the only one critical point of this function, and it is clear that this 1, 2 is inside this triangular region, right? Because 1 is somewhere here, 2 is somewhere here, so 1, 2 is somewhere here. So 1, 2 is lies interior to region R. Okay, so this point is from our step 1. Okay, then step 2. What is our step 2? We have to find the possible extreme points from the boundary. Okay, so first we consider this boundary, the line segment between 0, 0 and 3, 0. That is our OA. Okay, we consider OA. And what is the nature of our surface? Surface means our function on this line segment OA. Or what is the to identify the nature of the this function on this line segment OA? First, what is the equation of OA? Yes, along this line segment OA, it is clear that equation is nothing y equal to 0. Clear? Because this is our x-axis, so y equal to 0. So what is the behavior of this function on this line segment OA? That is nothing f of x0. We simply substitute y equal to 0. So this is the behavior of the function on this line segment. And what is the value? When y equal to 0, this term is 0, and this become minus 6x. Again, this term is 0 plus 7. So this is the nature of the surface or nature of the function on this line segment OA. Okay. Okay, this means what? This means along OA, our surface is nothing or our function is nothing. It is a straight line because this is a linear equation, minus 6x plus 7. Okay, that means above this line segment OA, our surface is like a line. So there is a natural question, is it an increasing line or decreasing line? So to identify the nature of the straight line, you simply differentiate. Then what is the derivative of this straight line? Here we denote this fx0 by ux, that is minus 6x plus 7. To identify the nature of that line segment above OA, you simply differentiate this ux with respect to x. So here the derivative is minus 6. And what is the meaning? This means that above this OA, if x is increasing, our surface is like this, decreasing, like in a straight line. Clear? Because derivative is negative means curve is decreasing and it is a straight line. So above the line segment OA, if x is increasing from 0 to 3, our surface is like a decreasing straight line. So which are the possible extreme values? This point is corresponding to 0, 0 and this point is corresponding to some 3, 0. It is clear that we have two possibilities. Either one point is a maxima and one point may be a minima. Okay, so from this analysis, we have two possible extreme points from the boundary, right? So thus the possible extreme points from this boundary are n points 0, 0 and 3, 0. Clear? Okay, next you have to find the possible extreme points on the edge OB. Okay, next boundary. So what is the shape of the surface along OB? We know equation of the line segment OB is nothing, equation of this line is nothing, x equal to 0. So our surface is nothing, f of 0y. Okay, so what is f of 0y? Yes, f of 0y is nothing, minus 3y plus 7. That will be v of x. Sorry, this is v of y. Yes, it is vy. So when x equal to 0, this become 0 and this also 0, this become minus 3y plus 7. Okay, again it is a straight line. That means above the line segment OB, our surface is a straight line. Clear? Above the line segment OB, our surface is a straight line. And there is a natural question, is it a decreasing straight line or increasing straight line above this OB? So you just take the derivative of this straight line, that is v dash of y, that is equal to minus 3. So what is the conclusion? This straight line is decreasing. That means if y is increasing, our curve is decreasing. Clear? So again it is like a straight line, a decreasing straight line. So and this point is nothing, this point is 0, 0, and what about this one? This is nothing, 0, 5. Okay, so again we have two possible extreme points, either 0, 0 or 0, 5. This may be a minimum point, this may be a maximum point. So from this edge we have two possible extreme point, one is 0, 0, other is 0, 5. Okay, and 0, 0 is common. Okay, anyway we have now 3 points, 3 possible points. Okay, then we have one more edge, that is AB. So next we have to check the nature of this function along this AB. Okay, so first we have to find the equation of this line segment. What is the equation of line segment passing through? What is the equation of the straight line passing through 3, 0 and 0, 5? Yes, you can use a 2-point formula, that is x2 minus x1 by x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1. So here you can choose, this is our x1 y1. So what the 2-point formula is, x minus 3 by x2 minus x1, that is 0 minus 3, that is equal to y minus y1, that is 0, y, this is our y2, 5, 5 minus 0. Okay, then you can cross multiply and this become 5 times x minus 3, right? That's equal to minus 3y. So what is y? Y is equal to minus 5 by 3 x plus 5. So this is the equation of the straight line passing through 3, 0 and 0, 5. Okay, so equation of the straight line is y is equal to minus 5 by 3x plus 5. Then next we have to analyze what is the behavior of the surface. What is the behavior of the surface above this line segment or on this line segment? Clear. So we know on this line segment there is a relation between x and y. So you simply replace y by this quantity on this function. That gives the nature of the function on this line segment. Okay. That is the nature of the surface above the line segment is f of x comma, instead of y we use minus 5 by 3x plus 5. So it is a function of x alone. And what is this? This is equal to 3x into, just replace y by this quantity. Okay. So our surface become 3x into, instead of y minus 5 by 3x plus 5 minus 6x minus 3 times replace y by the value of the straight line plus 7. Okay, upon simplification this surface become like this. Okay, let it be w of x because it's a function of x alone, so we can take it as a w of x. W of x is equal to minus 5x square plus 14x minus 8. Okay, and it is clear that above the line segment or on the line segment AB, our surface is not a straight line, it's a curve. It may be like this, whatever be. So we have to find the possible extreme points. Okay, so we simply differentiate it and equating to 0 to find the possible maxima and minima points from the surface. So you take the derivative, that is w of x is equal to minus 10x plus 14. Then equating to 0, what happened? Okay, that means minus 10x plus 14 equal to 0. So x is equal to minus 14 by 10. So that is nothing, 7 by 5. If you are substituting the 7 by 5 on our y, so y become minus 5 by 3 into 7 by 5 plus 5. Upon simplification, y value become 8 by 3. Okay, so what is the meaning? On the line segment AB, our surface is a curve, and curve has one local minima or maxima point because derivative is a 0. That means there is a critical point. Okay, so on the line segment AB, our surface may be like this or like this because anyway this has a critical point. At that point derivative equal to 0. Clear? So if this is the shape, then it has a critical point at somewhere here. If this is the shape, then this is a critical point at this point. Derivative is 0. Okay, then what happened? So we have 3 possible critical points on AB because one is the critical point. There are 3 possible extreme points on AB, right? One is this critical point and other 2 are the end points. If this is the shape, then maybe this is an extreme maximum, absolute maximum, and these 2 may be a absolute minimum. It is possible. Okay, so we have 3 possible absolute points, absolute extrema points from the line segment AB because the shape of the surface along AB is not a straight line, it's a curve with the one critical point. So we have 3 possible extreme points. They are 7 by 8, 8 by 3 and 3, 0 and 0, 5. Okay. Okay, now we have total 4 possible extreme points from the boundary 0, 0, 3, 0, 0, 5 and 7 by 5 and 8 by 3. And what is our step 3? In step 3, we have to evaluate the value of the function on all the points from these 2 steps. Okay. Then choose the absolute maximum and absolute minimum from the table. Okay. So next we are going to create a table. Okay, that means we have to compute the value of the function on these 5 points. 4 points from the boundary This is nothing. This is our 7 by 5, 8 by 3. Okay. 4 points from the boundary and 1 point from the interior. So this is the value of the function on these 5 points. And from this table, you can easily find absolute maximum and absolute minimum. Clear? And from this table, it is clear that absolute minimum at 3, 0 and its value is minus 11, and the maximum is 7 at 0, 0. Okay. Okay, this is the graphical representation of this function on this rectangle. Actually, we consider rectangle. Here y is varying from 0 to 5 and x is varying from 0 to 3. Okay, so this is a rectangle. On this rectangle, this is the shape. Actually, in our problem, we have to consider only a rectangle. So what is the shape of the surface on this rectangle? Rectangle means this is our rectangle. Clear? So we have to consider only the region above this rectangle to extremizing our problem. Okay, so our this point 7 by 5, 8 by 3, that is somewhere here. Clear? Somewhere here. This is our 7 by 5, 8 by 3. Clear? And 1, 2 is somewhere here. X is 1 and y is 2. So somewhere here. This is our x2. And these are our end point. Okay. So these are our possible point or 5 possible points here. And it is also clear that along our OA, we know that along OA our surface is a straight line. This is our OA. Clear? This is our OA next x direction. It is clear that along OA our curve is straight line. Edge is like a straight line. Clear? It is decreasing. That is our mathematical from our mathematical analysis we have like that. That is same as in our geometry. And what about our shape of the surface along OB? Again, it's a straight line and decreasing. That's also clear. It's a straight line and decreasing. Clear. And what about the shape of the surface along AB? Okay, it's a curve, either this shape or this shape. From this geometry, it is clear that the shape of the curve is like our second choice. Clear? That's why we have the 3 possible extreme points. So anyway, this is the geometry of above problem. Okay, this is your homework. Thank you.